Alright, I'm back again for a course concept video. And in this one I'm going to go through the whole wizard on this. And I'm going to do just a basic, let's do a new part. And I'm just going to do a basic rectangle here. Okay. Can I get in here? It's not starting up yet. Let's see. Toolbars. It's in there. Where'd it go? Nope. I can't get to it. Where is it? Let's go like this. Is it there? Oh, here it is. Oh, this is kind of a trick that happens sometimes too. So you can see I don't have my sketch bar up here. And you can right click in here and check toolbars and it shows it active. Toolbars, right click, toolbars, sketch toolbar, and it's actually over here. So what I'm going to do is I think I can just drag it and put it back in place here. Let's see there. Let me see if I can grab it again here. Drag it. And I don't think that's it either. Enable command manager. There it is. Okay, I'm thinking not the toolbar, but the command manager. And then this one I'll put here. And then can I swing this one? So you can kind of move this stuff around a little bit, but sometimes if you're stuck, like look on the sides or do a screen fit, and I think this one's overlapping here. Let's see. I think it goes like that. Okay. So in Sketch doesn't matter, orientation, origin doesn't matter. And I'll just put a rectangle here. I'm going to dimension this. I'm in. Let me go to inch. Pound second, edit. Dimension this as 10. That's fine. 4 inches is fine. Just so it's fully defined. Yes. And then fully defined sketch. Then I'm going to select features, extrude. And let me go a little bit. I'll go 2 inches. 2 point. Let me go 2 point. Oh, come on, my number key, my number pad. 2 point. There we go, done. Okay, so from here, I have a fully defined sketch and my base extrusion. So let's select the whole wizard. Now within the whole wizard, the property manager comes up, and remember there's two tabs, a type and a position. So, and then within the whole type, you have these 6 selections, right? Most commonly, you'll use a threaded hole. So I'm going to select, and they call it straight tap. I'm not a fan of the terminology because an internal thread can be cut with a thread mill. Trying to think, there's other ways to cut it without using a tap. They should just say threaded hole. So I'm not a fan of that terminology, but whatever. And you can see within the property manager, the area is gray. If I bring my mouse into the graphics view area, it shows what is selected is grayed out, the background. So, and what that does is if you look down here, it changes the rest of the property manager for the whole. So I'm going to select straight tap. And then the bottoming, that has to do with the lead of the thread. I think the tap tool should have more lead, so it has more distance where on the sample where the threads are not tapped complete. So if you're using a blind hole or you're making a blind hole that doesn't go through the part, probably better off using the bottoming, but it kind of doesn't matter. A tapped hole, you're probably good either way as far as the hole wizard goes for my projects. When you get in companies in the industry and you're using this, there's your coworkers might use different methodologies, and it's good to understand them and work off of someone else's experience. But for this class, I either want a bottoming or a tapped hole is fine. So I'm going to use, I'll go ahead and make from the drop down menu, I'm going to just make a quarter, let's do a quarter 20. Pretty common thread. Or actually, I'll make it a little bigger. Let's use a half 13 is here. So this is a standard. And you can show custom sizing. And I think the custom sizing, what this will do is it shows on the custom sizing for the thread here, it only shows the minor diameter of the tap drill size. And this could be an issue sometimes. I know I've made parts before that actually were threaded like with a roll tap. And we actually had to ream the hole to get the exact, not the location didn't matter, but the exact hole size. Because there was an application of the thread that was really difficult. So you really don't need to change this that often, but sometimes you do when you need to sometimes you can say, okay, this is a quarter 20 or this is a half 13, and then you might be using what's called a roll tap or aluminum tap. What's another thread? A form tap. Sometimes they call it a threadless form tap or something, or a fluteless form tap. So this would be a very different number from a standard tap drill size. So there's that. And then for this, I'll just actually I'm going to do a blind hole so you can understand the depths here. The depths are going to have a thread depth is here. Let's see, it should say thread depth there, and this will say, yeah, depth up to shoulder. Yeah, and this says depth to tip. So if you look at the pictures, honestly, this should always be depth to shoulder, so excluding the tip. Whenever you see a hole size on a drawing, or even a thread size or a hole size, whatever the depth size is, that does not include the drill tip or the tap tip. So I'm not exactly sure. This is actually a new thing. I don't remember this on last year's SolidWorks feature, so I'm not sure. I would always just select this one because this is going to show your actual thread depth here. Actually, this shows the blind hole depth, I think, not the thread condition. Yeah, because this is the thread. So the tap drill size will drill 1.38, and the thread will tap 1 inch, so you can screw the bolt in exactly 1 inch. This would be considered the minimum that you would want to thread in order for the bolt to fully engage and be strong enough for the size of the application of the bolt is standard. So sometimes you don't need this, but usually if you're going to tap, you're always going to tap 2 times the diameter. And then as you go deeper than the diameter, if you go deeper than twice the diameter, the clamping force or the holding force of the thread does not increase at the same rate of the depth of the thread. So in other words, if you just go 2 times the diameter, it should be enough to apply enough force to keep the fastener fully engaged in whatever application to hold the assembly together. If you go deeper, it's more time consuming, it's more cost to produce, and there's other factors involved. Your fastener size would generally be longer, so it'd add more weight and more cost in that regards as well. So, and then within the software, so it shows the end condition here with the tap drill size for a blind hole. The full thread depth, actually the tap drill depth is here in the blind condition. The thread depth would be 1 inch, and if you look, if I go up here and I select through all, there is no depth to any of these, right? Because the thread's going all the way through the part. So if I go back and select blind, then it comes back up with those values. And then the options, this is the display options. And I'm going to go ahead and select on this face, or if I go to positions now, select this face, and then select a point here and a point here. And I'm going to go back to type. Oops. Let me go back down here, and it shows there's 3 options here. This one is tap drill diameter, which is sometimes that's good. And then this shows cosmetic thread. I think this is new this year. We'll see what it looks like. And this shows removed thread. So I'll keep the tap drill diameter. I'm going to say yes, and it's going to display just through holes and to depth of the blind hole depth. And you'll see it has 2 sketches there, right? So sketch 3, if I open that up, it shows the diameter of the tap drill size and the depth to the shoulder, 1.38 to the shoulder. It does not include the drill tip. It just shows the profile of the revolved hole is what it's doing. It has the fixed point of the center point of the hole, right, that I've selected, and that's fixed on that face. It's not fixed to this edge or this edge, and that's why the other sketch is underdefined. And I'm going to go fix that, but then it shows the diameter here. This is 0.42. It's 0.4219 is the tap drill size, or the minor diameter, we also call it. And sometimes I worked with machinists and engineers where all they'll do is they'll just add the threaded hole here on the 3D part. And the machinist can know and just select on this, and they'll be able to measure this, and they'll know based on the tap drill size what the thread will be. In this case, it obviously tells you here, but a machinist should be able to know based on that the hole size. So that's one kind of a fast and easy way to do it. And if you do it this way, it's fine, honestly, because I see it in here. Or you can do a right click, edit feature, and we can also, let's see what cosmetic thread shows. I'm going to escape out of the feature again. And it does show kind of a shaded thread there with this arc is the major diameter, and this arc would be the minor diameter, the tap drill hole 0.4219, right? So that's fine too. The one thing is this, the cosmetic thread takes up some computing power, so there's that as well. So again, I'm in graphics mode, and this looks pretty good, but this sketch shows as underdefined. So I'm going to right click. I'm going to edit this sketch. And you can see these center marks are like not defined. So I can just drag these anywhere. And then if I exit, the holes move. So this is a 2-dimensional point. This has to be dimensioned. And it has to be dimensioned from point to edge. Or you can do point to point, but just make sure it's accurate. And I'm going to go 1. And from this edge to this point is also going to be 1. And then I'll do this one a little bit different. I'm going to make this point and this point. Can I make them horizontal? Yes, I can. But this one's still blue. I can move it this way, but I can't move it up and down. So I can dimension from this edge to here as 2 inches. Let me double click that and go 1.5. Move it kind of out of the way of the part origin there. And now I escaped the sketch, and now it shows it here as fully defined. I'm going to right click, open it again, and you can see that those points are black, and it shows down here fully defined. And then it shows also, I added the one sketch relation that this is defined horizontally from point to point. And then if I delete, let's say, this dimension, then these are both underdefined because now I can move them both because they're not constrained. If I do an undo, they're not constrained by this dimension. So keep that in mind. Hopefully that helps you with the whole wizard. I will show you also real quick. I'm going to exit out of here and show you the whole wizard. I should do this now. Not in Sketch, but let's see. It'd be a new sketch. Not a new sketch. In Features, whole wizard. And then I'm going to select, it would be not taper tap, but counter bore. And if I come in, I can customize. I almost always give you assignments. I think this is on the, it's on the midterm, and it's on the practice midterm. Then I'm going to do a, not a standard, but a, is there a custom sizing down here? Let's see, type, binding. Oh, right here, custom sizing. So I'm going to do this as, it shows it in millimeter. Oh, let me change this. Not this one. This one. That's not right either. Export. I think I did something wrong. But anyway, I can use metric. I don't want to use that. I'm going to try it again. I'm going to relaunch Whole Wizard. Because I don't think I'm in inch. So let's select counter bore. Yeah, and it shows ISO, but here it is, ANSI inch. And when I go to my custom sizing now, it'll be an inch. And I almost always have you change. This would be the through hole, let's say 0.2. This would be the counter bore size, 0.7. The depth would be 0.2. And then, can I do a through size? Yeah, let's do through all. So the depth, the drill point depth doesn't matter, or this, what do they call this? What does it say? The through hole diameter goes through now. And then you can do a far side countersink or a near side countersink. And I don't do this with the counterbores, even though you might do a deburr and you make it really small. But that would be in manufacturing, not necessarily in the design, depending. So I'm going to go to positions. I'll go to this face again, and I'll just put like one right here in the middle and say yes. And now you can see it goes through, And again, for the counterbore, it shows underdefined. So I need to go in and edit the sketch and smart dimension from this edge. Done. And then this edge to here. Let's try it again. Smart dimension from here to here. Make sure you do this on every time you use Hold Wizard. You need to constrain it in two directions because it's a two-dimensional feature. It's a feature on a two-dimensional plane that needs to be constrained on two dimensions. The dimension looks good. It shows fully defined. And again, you can look at, I'm going to exit that sketch, and I'll open the sketch of the profile that's defined within the property manager. And again, it shows the diameter, counterbore diameter, counterbore depth. This shows the through hole depth, but it goes through, so it's exactly 2 inches. And then it shows the diameter of the through hole diameter. So hopefully that helps, and that's a little concept video on the Hole Wizard. Certainly go through this if you have questions on this, and then if you have further questions, please contact me direct. Thank you.